Wagner. And for my first ever podcast, I would like to talk about the scientific revolution and ultimately the history of science. A class I took in the fall of 2020 was conducted by the professor emeritus at then Piedmont College, titled Critical Issues in World History. Named he was named Dr. Buzz Singer. He has since retired, but the final for Dr. Singer's course was on Was the Scientific Revolution Revolutionary? The same question is disguised in the Georgia Common Core State Standards, State Standard World History 13. Examine the intellectual, political, social, and economic factors that changed the worldview of Europeans from the 16th century to the late 18th century. Subsection A. Explain the scientific contributions of Copernicus, Galileo, Kepler, and Newton, and how these ideas changed the European worldview. Now, Mitchell and Mitchell are the authors of the textbook that I'll be primarily using. Uh, it was our textbook in Dr. Singer's class, and it was published in 2019 by McGraw-Hill. It's titled "Taking Sides: Clashing Views in World History," Volume One, Fifth Edition. In the preface, they mention finally several issues show the power of ideas in shaping the history of civilizations. Now, Dr. Singer had always encouraged us to pick a side on these issues, and for his final, I knew this would be no different. All right, before discussing these issues, our class and textbook covered the Reformation, Queen Elizabeth, and the European witch hunts of the 15th to 17th centuries. But this issue begins with the Yes section is written by Edward Grant from When Did Modern Science Begin? Published by the American Scholar in winter of 1997. The No section is written by Stephen Shapin from The Scientific Revolution, published by the University of Chicago Press, 1996. The issue summary goes as the Yes section is written by distinguished, I think that's sarcasm, Professor Emeritus of History and Philosophy of Science Edward Grant argues that there was a scientific revolution, a revolution in science that took place in the 17th century. However, it may have been delayed by centuries if several key developments between 1175 and 1500 had not paved the way for it. The No section, No is written by Professor of Sociology and Historian of Science Stephen Shapin, argues that we should question the idea of a scientific revolution, suggesting that there was no philosophical break with the past and rejecting a single time/space event we might call a scientific revolution. And those key words from the No section that they're hinting at is philosophical break and a single time-space event we might call a scientific revolution. But Mitchell and Mitchell then dig in. When you open a history textbook, you will find it conveniently divided into chapters and units with titles that mark the major turning points of history. One of those titles in a text on world history or Western civilization is likely to be the scientific revolution. Known as periodization, this tendency of historians to provide interpretive groupings of events has recently been subjected for reappraisal. And that's an important word. We'll get back to that word. If where you stand determines what you see, then the very act of labeling periods of history makes judgments about what is important and valuable. Let me say that one more time. If where you stand determines what you see, then the very act of labeling periods of history makes judgment about what is important and valuable. Traditional schemes of periodization, for instance, have taken the experiences of white men as the standard and ignored the often quite different lives of women and minorities. If only the concerns of the powerful provide the basis for interpreting historical significance, then much of history will be left out. The assumption behind periodization is that there are moments when the path of history is rerouted, when a sharp break with the past leads to a new kind of experience or a new way of understanding the world. One of the questions historians must ask, therefore, is whether a particular event or series of events represents continuity with the past or discontinuity from it. Traditional periodization has seen the scientific revolution as a classical example of discontinuity, as a sharp break with the medieval past in the ushering in of the modern world. Recently, however, historians have taken a fresh look at the late 16th and early 17th centuries and have wondered how scientific and how revolutionary this period actually was. A danger historians must also remain alert to is called presentism, the tendency to judge and interpret the past by the values as well as the standards and the concerns of the present. From the perspective of the early 21st century, for example, we might be tempted to view the Industrial Revolution as replacing back-breaking labor with the power of machines. People living through what we have come to call the Industrial Revolution, by contrast, might have focused on the breakup of the family, as individuals left the home to do wage work in the substitution of the factory for the productive unit in the home. One of the questions we must ask ourselves is, do the people living in the 17th century think something revolutionary was going on? And how much of a break with the past did the scientific discoveries represent? This question is a philosophical as well as historical one. At issue are how we understand key terms such as science and revolution, as well as what we interpret what philosophers call epistemology or knowledge theory. You can both go Google those. Both historians agree that key people in the past understood what they were doing as a break with the past. Where they disagree is how to evaluate the past in the context of what we know in the present. Deconstructing or taking apart text to reveal their hidden meanings has led many to question whether it is ever possible to have a single universal meaning for a term like science. What the word may have meant to people practicing it in the 17th century may be worlds away from what it means to people practicing it today, and those of us outside the scientific community in either period probably have less idea about what may be at stake. Thomas Kuhn, whose widely read 1962 book, The Structure of Scientific Revolutions, also published by the University of Chicago, 1962, has shed some light on this controversy. Combines continuity with discontinuity. Revolutions, Kuhn writes, are the occasional dramatic breaks from periods of what he calls normal science, when everyone in the scientific community operates from within an accepted paradigm. Revolutions occur when experiments repeatedly do not yield the expected results, or when data do not conform to predicted outcomes. Scientists struggle to make the new material fit the old paradigm. Those who challenge the paradigm are marginalized or forced to conform. When it becomes clear that the paradigm has broken down, a new paradigm is accepted. Then everything is explained in the terms of the new paradigm. Students are educated in the new paradigm. Textbooks are written to reflect it. Research takes it as its starting point. Has the world changed, or only our way of explaining it to ourselves? After 1700, science had incorporated Copernicus's theory of heliocentric system. Valsius's anatomy of the human body had spread. New worlds had been discovered in the heavens and the earth. Francis Bacon's Novum Organum had established the scientific method of observation and experiment. William Harvey had demonstrated the circulation of blood. René Descartes had divided reality into mind and matter. And Isaac Newton had proposed the principles of classical mechanics or physics. Would these taken together constitute a paradigm shift? For Edward Grant, there was undoubtedly a scientific revolution. Remember, he was the S section. He sees the fields of astronomy, cosmology, and physics undergoing momentous changes over the 16th and 17th centuries. However, he also documents a series of events, the translation of Greek and Arabic scientific philosophical works into Latin, the formation of medieval university, and the emergence of a class of theologian natural philosophers, without which the scientific revolution would not have occurred when it did. Stephen Shapin begins his introduction with a boldly revisionist statement. There was no such thing as the scientific revolution, reflecting a postmodern view of the world. Shapin questions whether it is even possible to speak about an essence of something called science. Instead of a single, discrete entity, he sees a wide variety of ways of understanding, explaining, and controlling the natural world. If we list the characteristics of the so-called revolution, Shapin thinks we will find that experimental method, mathematical approaches, and even mechanical conceptions of nature were both advocated and rejected by people who thought of themselves as scientists. Both Grant and Shapin see continuity with the medieval past rather than a radical break from it. And both would agree that the past did not become the modern world at a single historical moment. Summarize the difference between them in your own words. Be precise in where they part company. What constitutes the turning point for Grant, and what permits Shapin to deny Grant's claim? All right, I'm not going to read all of Grant and Shapin's work. That podcast would take over an hour, but I have already told you how to retrieve them, and I will also tell you what our textbook authors, Mitchell and Mitchell, want us to know. When it comes to Grant, they kind of already hinted that Grant's citing the translations of text from Arabic and Greek into Latin, which I can just go ahead and tell you now that that's very, very ethnocentric. And then his other big accomplishment and big monument for the scientific revolution is the founding of the modern university, which that's also very ethnocentric. And essentially, all he's saying is that knowledge was systemized, or knowledge or science was systemized. That doesn't really constitute a revolution, in my opinion. Grant also said, although science has long history with roots in Egypt and Mesopotamia, it is indisputable that modern science emerged in Western Europe and no place else. So, again, he's saying science was not institutionalized. Grant's argument is that experimental and institutionalized science constitutes a revolution. We might start to be catching the vibe now that the scientific revolution may not have been that revolutionary. He also had a possible sneak diss to Stephen Hawking and the Big Bang singularity. He said, what must be emphasized, however, is that momentous changes in the exact sciences of physics and astronomy that epitomizes the scientific revolution did not develop from a vacuum. So when you're reading that, you already start wondering, like, are you mad, bro? So Mitchell and Mitchell always have on the exploring the issue page, and they always have a critical thinking and reflection section with several questions. Question 2 says, Thomas Kuhn, in his book, The Structure of Scientific Revolutions, describes periods of normal science followed by periods of revolution in which experiments do not yield expected results. For example, at those points, a paradigm is overthrown and another one takes its place. Paradigms are vast, complex, coherent views of reality that are so taken for granted that they become invisible. With this brief explanation in mind, critically evaluate whether what textbooks typically describe as the scientific revolution represents a paradigm shift. And then question 3 says, in the 20th century, the discovery of quantum mechanics and relativity theory represented what many would agree was a paradigm shift. In what ways did these two theories revolutionize our understanding of ordinary reality? Critically research and analyze this phenomenon. Well, I did critically research, and I will share a few of them with you. The first one's from The Great Courses, published by The Great Courses. It's by Dr. Stephen Gimbel, and his series is called Redefining Reality. But Dr. Gimbel believed, he was a big disciple of Thomas Kuhn, actually, and he claimed that a redefinition of reality typically accompanies scientific progress. He also tells us that Einstein's new mechanical laws of objects replaced those of Newton's in the scientific revolution as fixed, unchanging, and never interacting with each other. But according to Einstein's quantum entanglement, everything is connected. The concept of fields came from Einstein, as well as the quantum theory of relativity, just like Mitchell and Mitchell told us about. The universe is now understood as a single interconnected entity. He also talked about Baruch Spinoza, who heavily influenced Einstein in his thinking, philosophical thinking. Baruch Spinoza lived from 1632 to 1677, believed that God was, this is a quote, God was not some separate, distinct entity from the world. God is the world. Everything we think of as individual things are not really discrete objects, but just modes of the whole, aspects of God. When Einstein was once asked if he believed in God, he replied with, I believe in the God of Spinoza. Another source I want to talk about is Dr. Don Lincoln, also from the Great Courses. It's a 2017, I guess, lecture, video called The Theory of Everything, The Quest to Explain All Reality. And again, that's the Great Courses as well. Episode 1 is called Two Prototype Theories of Everything. It talks about the structure of an atom, then something very significant. In 1964, the situation changed when physics found that atoms are made of even smaller particles, still, what we call quarks. Now, particle physics and Sean Carroll's Particle at the End of the Universe, which is from 2012, is a completely different metaphysical rabbit hole, but it's also very much part of this new quantum revolution, maybe second quantum revolution. Now, in my own private research on the subject matter to update, I found Einstein's Quantum Riddle, which is a PBS documentary from 2019, PBS Nova, that I would highly recommend everybody going to watch. Okay, so in 1927, Einstein traveled to Brussels to attend a meeting about a new theory that described the microworld of atoms and tiny particles, quantum mechanics. At this meeting, Einstein and Niels Bohr got into a heated debate that would lead to the discovery of quantum entanglement, a concept that would haunt and trouble Einstein for the rest of his life. At these meetings was quite possibly the greatest meeting of minds ever. They include Max Planck, Einstein, Bohr, Schrödinger, and Heisenberg, just to name a few. More than half of the 29 men won the Nobel Peace Prize. Their experiments proved that atoms do not look like we had thought. They were not solid little spheres. They actually seemed fuzzy and undefined. The results from the 1927 Solvay conference were straight up weird. It said that a particle, like an electron, isn't physically real until it is observed. For Einstein, the idea that particles only pop up into existence can't be real. It was akin to magic. He even said, Do you really believe the moon is not there just because you aren't looking at it? Einstein would challenge the biggest proponent of quantum entanglement, Niels Bohr, daily with challenges, and every night Bohr would have an explanation. Einstein still had questions when he left Solvay, and he would not accept quantum mechanics for its unpredictability. And because of this, he discovered something even weirder. Now, when World War II broke out, Einstein moved to America and worked/studied at Princeton, New Jersey. When he, Podolsky, and Rosen discovered something miraculous, quantum mechanics was incomplete. They argued it in their 1935 paper, also called the EPR, that the equations of quantum mechanics predicted an impossible interconnection between particles, seemingly magical. This 1935 paper has become Einstein's most referenced paper of all time. It concluded with Bohr's quantum mechanics being incomplete. Bohr responded that one particle can mysteriously affect the other. It leads us to quantum entanglement. And Einstein dismissed it and said it was spooky actions at a distance. Einstein still had a lot of questions about quantum entanglement, this spooky connection, and his questions actually remained unanswered until the 1960s, when John Bell became a particle physicist at CERN in Geneva. At night, Bell worked on solving these spooky mysteries Einstein called quantum entanglement. Okay, so Bell insisted that quantum mechanics needed further thought. We cannot simply say that Bohr solved everything. And in 1964, Bell proved that Einstein and Bohr's theories did disagree. And we could actually test to see if we live in Bohr's world or Einstein's. When John Clauser, a brilliant experimental physicist, read Bell's article and decided to give it a shot. He tested it and discovered Bohr was right. PBS then said the first people to react to the quantum revolution were actually not scientists, they were hippies. And then Nova and PBS began to theorize quantum mechanics with Fritjof Capra's The Tao of Physics or Gary Zhukov's Dancing Wu-Li Masters. Two books very worth reading. In the years following World War II, quantum mechanics helped develop the first lasers at the Bell Institute in New Jersey. The entire digital revolution, computers, transistors, followed, all made possible by the quantum theory. Okay, back to Mitchell and Mitchell, my history class textbook. Under critical thinking and reflection, that's where we were last. Under question 6, it says, having read both selections, which argument do you find more compelling, the claim of continuity or the claim of discontinuity? What specific elements make one interpretation more compelling? Critically discuss. Then the final question, 7, says, it is only by taking a very long view that we are able to look back at the sweep of history and chunk it into periods for study and research. What clues might there be that a society is undergoing a paradigm shift in real time? Are we undergoing a paradigm shift now? Critically research, analyze, and make your case for or against either claim. So what are we to believe of this? Is this the age of discontinuity? There's clearly a spooky entanglement, an interconnectedness in this reality, or whatever that is, right? Mitchell and Mitchell always list a few. They conclude their exploring the issue page with additional resources, and they list a couple of additional resources. And from these sections, I'm telling you, is where aspiring historians find books of gold. But in this one, they list Thomas Kuhn's book, obviously the one that we already talked about, and then they say a more modern collection of essays appears in Reappraisals of the Scientific Revolution, edited by David C. Lindbergh and Robert S. Westman, Cambridge University Press, 1990. In it, essays by philosophers of science and historians consider conceptions of science and the relationship between philosophy and science. They also examine what is included in our definition of science and question the historical marginalization of disciplines such as medicine and natural history. This Cambridge University Press 1990 book was really written by an all-star lineup of historians of science and philosophy. The book that's edited by Lindbergh and Westman is over 550 pages. In regards to their definition of science and the historical marginalization of disciplines such as medicine and natural history, this is all I'm really going to say about that. On page 2, they say the return to antiquity. This was by David C. Lindbergh. The return to antiquity was seen by many as marking the beginning of a new age. The goals were classicism in literature and the arts, educational reform, and the purification of religion through a return to primitive origins. Protestant authors were especially apt to see a connection between the return to ancient sources and the Reformation of Christianity. A current Galileo search on spirituality and religion and science, or Capra's Tao of Physics, or Zhukov's Dancing Woolly Masters, all would reveal a 2020 article out of the Journal of Religion and Popular Culture by Linnell Cady titled Wild Beasts of the Philosophical Desert, Religion, Science, and Spirituality in a Post-Secular Age. I wanted to include this in regard to the standard mentioned in the introduction. In this 2020 article, Cady claims, evident in the book titles, Capra and Zhukov were both eager to illuminate the parallels between quantum physics and Eastern mystical traditions. They argue that the alignment between science and spirituality is made possible by quantum physics' revolutionary overthrow of the Cartesian Newtonian model that has dominated scientific and modernist thinking more generally. Then Cady finalizes her findings in naming two more wild beasts of the philosophical desert in Whitley Strieber and Jeffrey Kripal in their book Supernatural: Why the Unexplained is Real. Kripal is the leading expert in paranormal activity, and Strieber is for the extraterrestrial field. Strieber's most famous for his book The Greys, which had a film based on it called Dark Skies. If you've ever seen that. In what is quite the metaphysical rabbit hole, can this really be discussed in predominantly Protestant schools? Where does the mind and psychology, Freud and Carl Jung's synchronicity come into all of this? What about Hugh Everett's Many Worlds interpretation of quantum mechanics, Princeton Legacy Library, published in 1973? This particular source was dropped on Netflix's Stranger Things recently. Just a few years ago, I had a near-death experience and a traumatic brain injury, TBI. I was also in a coma for a week, an experience that I can't even begin to explain. But my time from my coma is perhaps best explained by Sturgill Simpson in his song Turtles All the Way Down from the album Metamodern Sounds in Country Music, which is also a nice rendition on this very subject. Thank you, and until next time.